Hello. Today we're going to have a look at the second key area from the waves unit in National 5 Physics, the electromagnetic spectrum. So, the electromagnetic spectrum is a range of transverse waves which all travel at the speed of light, 3 times 10 to the power of 8 meters per second in a vacuum. And this is a spectrum, starting on the left-hand side with high frequency, short wavelength waves which have the most energy, are gamma rays, and then in order of decreasing frequency, increasing wavelength, and reducing energy, we go from gamma rays to X-rays to ultraviolet light to visible light to infrared rays to microwaves and then radio and television waves on the far right. We have to remember the order that these come in. A good way of remembering that is to come up with a mnemonic. The mnemonic I use is: good xylophones usually vibrate intensely, meanwhile tambourines rattle. Now, we also need to know a little bit about each part of the spectrum. We have to be able to state a detector of that type of radiation, an emitter of that type of radiation, and a use for that type of radiation. So let's go through them. Firstly, gamma rays. Gamma rays are the most high frequency rays which carry the most energy. They are emitted from radioactive nuclei. They are detected using a Geiger counter or a Geiger-Müller tube and counter, and can also be detected by photographic film. They're used as radioactive tracers in medicine and also in radiotherapy. So this picture here on the right hand side is a picture of an angioplasty being done where a radioactive liquid is injected into the patient's arteries, and it can then be viewed outside the body to show up any blockages in the arteries. This picture here shows a patient undergoing radiotherapy. X-rays, slightly less high frequency, slightly less energy, and a slightly longer wavelength than gamma rays. They are emitted when high-speed electrons are slowed down very quickly, usually during a collision with a metal. They're detected by photographic film, and they're used as a way to see inside the human body. For example, this picture here showing some broken bones. What happens is the X-rays are absorbed by the bones but can pass easily through the softer tissues in the body. That creates a shadow of the bones on the photographic film and allows us to see the bone structure inside. Ultraviolet, slightly shorter, slightly longer wavelength than X-rays, slightly less frequency, slightly less energy. They are emitted during electrical discharges and also by stars. They can be detected by photographic films, a photodiode and meter, or by fluorescent materials. And they're used to treat skin conditions, detect forged banknotes, and for invisible security labels. This picture here is actually showing a newborn baby who was born with a condition called jaundice, and they are placed under a UV lamp to treat that condition. Visible light, slightly lower in frequency, slightly longer wavelength, and slightly less energetic than ultraviolet. Visible light is emitted when electrons move between energy levels in an atom. They can be detected by photographic film, by a photodiode and meter, or indeed by the retina of your eye. And they're used to enable us to see. That there is the visible spectrum of visible light. Infrared, out the red end of the visible spectrum, slightly longer wavelength, slightly lower frequency than we are able to see. It is emitted by hot objects. It's detected by a photodiode and meter, and it's used in night vision and in the treatment of muscle injuries. This little clip here shows a bear catching a salmon in a river. And we can see the difference in temperature of the bear, much hotter than its surroundings, and it shows up as white on the screen due to the amount of infrared radiation it's emitting. Microwaves. Microwaves are detected by an aerial and receiver, and also emitted by an area and receiver. They're used in radar, mobile telephone communications, satellite broadcasting, and in heating up food. This little animation here shows us what happens if you were to put your mobile telephone inside of a microwave and turn it on. And finally, radio and television. Radio and TV waves are emitted and detected by an aerial along with a transmitter and receiver, and is used in TV and radio broadcasting. Now, the electromagnetic spectrum, as we said, are all transverse waves, so problems can be solved about the electromagnetic spectrum using the same formulas that we talked about in the first key area. F equals n over t, frequency equals number of waves divided by time. Period equals 1 divided by frequency. Speed equals distance divided by time. And speed equals frequency times wavelength. When carrying out problems using the electromagnetic spectrum, please remember that the speed of electromagnetic waves is 3 times 10 to the power of 8 meters per second, the same speed as light in a vacuum. You will not necessarily be given the speed in the question. You have to remember this. Okay, why not try some problems now if you watch the accompanying video about key area questions for the electromagnetic spectrum key area. Bye for now.